Let's look at compositions involving inverse trig functions. For example, let's find the exact value of tangent of arc cosine of negative 5/6. Now this here is an angle, so let's call it theta. In other words, let's let theta equal arc cosine of negative 5/6. And therefore, if this is theta, then we're looking for tangent of theta. So if theta is equal to arc cosine of negative 5/6, that means that cosine of theta is equal to negative 5/6, and moreover, theta is in quadrant 2. Now, why is theta in quadrant 2? Well, looking here, we see that cosine of theta is less than 0, which means there's two possibilities. Either theta is in quadrant 2 or quadrant 3. However, remember, looking back up here, theta is equal to the arc cosine of negative 5/6, which means that theta also has to be in the range of the arc cosine function, which, remember, the range of arc cosine is the interval 0 to pi. And therefore, theta cannot be in quadrant 3, which means theta is in quadrant 2. And therefore, we can draw the following triangle. Because remember that cosine of theta is equal to x divided by r. And this is equal to negative 5 divided by 6. And notice over here we're putting the negative with the x because x is negative in quadrant 2, and r is always positive. And therefore, by the Pythagorean theorem, we can find y. That is, x squared plus y squared is equal to r squared, or negative 5 squared plus y squared is equal to 6 squared, or 25 plus y squared is equal to 36. And therefore, y squared is equal to 36 minus 25, which is 11. Or y is equal to plus or minus the square root of 11. But which one do we choose, the plus or the minus? Remember that y is in quadrant 2 here. And in quadrant 2, y is greater than 0. So we're going to choose the positive value. That is, y here is equal to the square root of 11. Now remember, looking back up here, we're looking for tangent of theta, which is equal to the y-coordinate divided by the x-coordinate, which is equal to square root of 11 divided by negative 5, or negative square root of 11 divided by 5. And this is an example of how we work with compositions involving inverse trig functions. Thank you, and we'll see you next time.